Hi, my name is Joan Ling, and today I would like to talk about solving non-loading questions. First, let's talk about the introduction. Mathematical reasoning is one of the most important skills in learning mathematics. It is not only about calculating numbers, but about understanding relationships, identifying patterns, and drawing logical conclusions. Through mathematical reasoning, we justify why a solution was, not just how to find it. This presentation applies reasoning through Poya four-step model, which consists of understanding the problem, devising a plan, carrying out the plan, and finally looking back at the solution. Now, let's move to the problem. A school has a 100 identical pencils that need to be packed into the box. The box comes in three fish sizes. A small box can hold 6 pencils, a medium box can hold 9 pencils, and a large box can hold 20 pencils. We need to find all non-negative integer solution for the equation 6x plus 9y plus 20z equals 100, where X, Y, and Z represent the number of small, medium, and large boxes, respectively. Here, we can summarize the mathematical representation. Each variable represents the quantity of a certain box size, and our goal is to identify all combinations that actually total 100 pencils. The equation 6x plus 9y plus 20z equals 100 forms the basis of our mathematical model. This type of equation is known as a linear diverging equation, which involves integer solution. In Poya's first step, we must fully understand the problem. We know that the total number of pencils is fixed, and all boxes must be completely filled. Therefore, X, Y, and Z must be non-negative whole numbers. This condition ensures that our solution remains realistic and practical for real-world packing situations. In the second step, we devise a plan. To simplify the equation, we can fit the value of z because the number of large boxes directly affects the total number of pencils. Since each large box holds 20 pencils, z must be less than or equal to 5. Substituting z value into the equation allows us to find possible combination of X and Y. This strategy avoids random guessing and ensures logical calculation. The third step is to carry out the plan. Here is the table showing the possible result for each z value. When z equals 2, we get 4 valid combinations. X equals 10, Y equals 0, X equals 7, Y equals 2, X equals 4, Y equals 4, and X equals 1, Y equals 6. Lastly, when Z equals 5, we have X equals 0 and Y equals 0. These are the only valid integer combinations that satisfy the condition. After finding the potential solution, we verify each one by substitution. All 5 combinations 10, 0, 2, 7, 2, 2, 4, 4, 2, 1, 6, 2, and 0, 0, 5 produce a total of 100 pencils. Verification confirms that reasoning process is accurate and consistent with the mathematical model. This step ensures that every answer is valid and logically justified. Let's visualize the results. This table shows all valid combinations and total number of boxes used. For example, the combination 005 uses only 5 large balls, which is the smallest total. A box graph can also be used to query compare the total balls across all possible solutions. Data representation helps us interpret the result more effectively. Based on the analysis, the combination that uses the fewest total balls is 005. This solution is the most efficient because it minimizes the number of balls needed for packing. In a real-world situation, this would save material space and time. However, other combinations like 442 offer a more balanced distribution of both sides. This shows how mathematics can optimize practical decisions. In this test, the use of bound algebra equation and table is justified because they clearly illustrate the relationships among variables. The table helps to systematically identify very integer solutions, while the graph allows for easy visual comparison. This combination of numerical and graphical representation enhance logical reasoning and support decision-making in problem-solving. Through this test, I realized that mathematical reasoning encourages structured problem-solving and deeper understanding. Using Poya method helped me stay organized and avoid unnecessary calculation. The test also strengthened my ability to explain and justify each step, which is an essential part of mathematical communication. It reminded me that mathematics is not only about computation but also about logic and reasoning. This problem reflects the kind of reasoning used in real-world applications such as logistics, packaging, and production planning. In this area, mathematical reasoning helps to make cost-effective and efficient decisions. It also demonstrates important mathematical skills like logical deduction, pattern recognition, and systematic verification, which are valuable in both education and daily life. To conclude, mathematical reasoning is a powerful tool for solving real-world problems. By applying Fourier four-step process, I was able to find all possible combinations for packing 100 pencils into box. The best solution, which used only 5 blocks, so the effectiveness of logical reasoning and algebra thinking. Overall, this day highlights the beauty of mathematics as both a sign of logic and a mentor of problem solving. Thank you.